Alright, welcome to lesson 13.4. These last two lessons are going to be about the same topic called the quadratic formula. So your aim today is that you can use the quadratic formula to solve quadratic equations. So the quadratic formula is really useful. It's kind of a save-all. If you're not sure of what step to make when you're trying to solve a quadratic, you can always use the quadratic formula. So even though in your notes we have this exercise 1, I want you guys to skip exercise 1 because we didn't talk about completing the square. So skip exercise 1, let's go straight to the definition of quadratic formula. So the quadratic formula looks like this. For the quadratic equation, ax squared plus bx plus c equals 0. The zeros, or roots or solutions, can be found by using this equation or formula. Okay? So it's really important that the quadratic function has to be in standard form first. So let me show you kind of how this works. And by the way, this right here, you do not have to memorize. They will provide it for you on the Regents exam. So you don't have to memorize this formula. It will be provided for you on the reference sheet. Okay? So let me show you how this works in the first exercise. Okay, so we have the quadratic x squared plus 8x plus 3. So the first thing we have to do is identify a, b, and c. So a in this example is that invisible 1. So I know that a equals 1. And b equals 8. So there's b is 8. And c is going to be this positive 3 here. Okay? So now that I have all of my A, B, and C defined, now all I have to do is substitute them into the formula. Okay, so I'm going to carefully substitute these values into the quadratic formula. So I'm going to start by writing x equals, the first part here says negative b. So I'm going to put minus sign, and then I'm going to put b in parentheses. What is my b value? Well, I just determined that b is 8. So I'm going to plug in 8 for b. Then the next part of the formula here says plus or minus. So I'm going to put plus or minus, and then this big square root symbol. Under the square root symbol, I'm going to put b squared. I'm going to put that in parentheses as well. So b again was 8, so I'm going to put another 8 here. The next part says minus 4 times a times c. So I'm using parentheses to protect my signs. Even though these are all positive numbers, parentheses help me make sure I don't have sign errors. So anytime you plug something in, make it in parentheses. So a is 1, so I'm going to plug 1 in for a right here, and c is 3. So I'm going to plug in 3 for c. Then the next part of the formula is this division, so I'm going to put divided by 2 times a. So it's over 2 times a, and we already said that a is 1. So the parts in black are parts of the formula that you don't change. But every number that I'm plugging in, the b, a, and the c, those are the numbers in color that I had to replace. And now all we have to do is simplify. Now this might take a few steps to simplify using PEMDAS. The calculator will help you, but it's really important to try and simplify this step by step. So this negative parentheses 8 reduces to just negative 8. We keep the plus or the minus. Simplify what's inside the radical. 8 squared is 64. Minus 4 times 1 times 3 is 12. All over 2 times 1 is 2. I'm going to simplify again, and this time I'm going to simplify underneath the radical. So negative 8 plus or minus 64 minus 12 is going to be a 52 divided by 2. Okay, now here's where we have to reduce this radical. So the square root of 52, see this square root of 52 right here? I'm going to take this square root of 52, this right here, and I'm going to reduce it off to the side. So I have the square root of 52, and I know the square root of 52 is the same thing as the square root of 4 times the square root of 13. So the square root of 52 is really 2 square root of 13. Okay? So now, when I go to reduce this, I'm going to now replace the square root of 52 with the 2 square root of 13 over 2. Okay? So now what happens is I got to deal with this plus or minus. So I got to deal with this, sorry, not the plus or minus, but the 8 divided by 2. So do we see this negative 8 divided by 2 and this 2 divided by 2? Remember the butterfly thing we did a long time ago where if you have two numbers divided, you can divide both of them? So this is actually going to reduce to negative 8 divided by 2 is a negative 4. And 2 divided by 2 is just 1, so we're going to ignore that. And we just get, this cancels out to 1. And I get negative 4 plus or minus 13. Okay, so I can say my two answers are x equals negative 4 plus the square root of 13, or x equals 4 minus the square root of 13, negative 4. Okay, so these are my solutions. Now this was a lot of steps and it's a lot of simplifying. Okay, so you've got to really be careful with your signs, and you can use your calculator to help. Okay, so let's take a look at another example. Let's take a look at the second example, at the next example. Students often prefer the quadratic formula to factoring or completing the square to find the zeros because it's so algorithmic in nature, meaning that it always can be used every time. So exercise 3 says, consider the quadratic equation 2x squared minus 9x plus 4 equals 0. Part A says, first solve this equation by factoring. Okay, so factoring means the x method. So when I see factoring, I'm either going to think GCF or x method. So I'm going to make my x. I multiply the 2 and the 4 to get an 8 on top, and then the negative 9 goes on the bottom. Two numbers that multiply to 8 but add up to negative 9 is negative 8 and negative 1. So I get two factors of x minus 1, x minus 8, and I'm going to set it equal to 0 so I can solve. This becomes x minus 1 equals 0, and this becomes x minus 8 equals 0. And then I just solve each of these to get my answer of x equals 1, and add the 8 over to get x equals 8. So by factoring, I get a positive 1 and a positive 8. The quadratic formula should give you the exact same solutions. Okay, so the first one was quadratic formula, first one was x method, and now we have the quadratic formula. Okay, so when I plug I'm going to write this again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm just rewriting the quadratic formula to help me. Okay. Now I'm going to first find my a, b, and c. So a in this is going to be this 2 right here. So a is 2. B is going to be a negative 9. Watch your sign. B is negative 9. And C is going to be a positive 4. Now that I have A, B, and C, I'm going to plug it into my formula. So x equals negative parentheses plus or minus the square root, and, okay. And notice I'm just kind of making parentheses where I have to plug things in. Kind of run out of room over there, sorry. So I put parentheses in places that I have to plug stuff in. This helps me kind of know what my formula is versus all the things I need to plug. Okay? So now I'm going to plug everything in. So wherever I see a B, I'm going to plug in a 2. So there's a 2 that goes here, and a 2 goes here. Then I'm going to do A. Oh, sorry, I did it wrong. A is 2. I made a mistake. How easy it is to make a mistake? I need to plug B into here. And B is not 2. B is negative 9. There we go. Okay, now I'll plug in the A. A is 2, and it goes here and here. And then C is 4, and it goes over to here. Okay? Now I have to simplify. So I'm going to start simplifying. I get x equals, be really careful here, this is a negative and a negative, and two negatives give you a positive. So this becomes positive 9 plus or minus the square root. This is negative 9 squared, which gives you an 81. And then 4 times 2 times 4 is 32. So you're going to have 81 minus 32 all over 2 times 2, which is 4. So let's simplify again. Keep the 9 plus or minus. 81 minus 32 is going to give us a 49, which is nice because that's a perfect square. Whoa, I don't know how I just did that. Okay. Divided by 4. We'll keep simplifying. Luckily here we can actually reduce this square root, so we get 9 plus or minus 7, because the square root of 49 is 7, divided by 4. Now, here's where the problem is going to break off into 2 pieces. So we're going to have the piece that is x equals 9 plus 7 divided by 4, and the piece that says x equals 9 minus 7 divided by 4. So then we simplify these each. 9 plus 7 is 16 divided by 4, and 16 divided by 4 gives us 4. And x equals 9 minus 7 over 4, which is 2 over 4, which gives us 1/2. So in a perfect world, when you do the quadratic formula, you should get the same answers we got here. So what did we do wrong? Well, this tells me that I must have done something wrong with my either x method or quadratic formula. And I'm just now remembering that this x method had a coefficient that was a 2. So what did I forget to do? I forgot to divide each of these by 2. So the quadratic formula is kind of a really good check to see if you're doing your work correctly. So all of this right here, I have to redo. So this right here, this negative 1/2, I'm going to pull it out to get 2x minus 1. And this reduces to negative 4, so I get x minus 4. Then when I set them each equal to 0 and solve, add the 1 to both sides, 2x equals 1, and divide both sides by 2. There I get my answer of 1/2, and the other one will give me a positive 4. X minus 4 equals 0, add the 4, and I get x equals 4. So when you do factoring and you do the quadratic formula, you should get the same answers, 4 and 4, 1/2 and 1/2. So sometimes the quadratic formula can be used to check your factoring, and sometimes if you can't factor it, there's a lot of equations that just don't work. You can't factor them correctly. You have to use the quadratic formula. Okay? And that kind of brings us to my to this next problem. The quadratic formula is particularly nice when the solutions are rational numbers and thus cannot be found by factoring. So there's a lot of quadratics that the solutions you can't factor. So sometimes we have to place the answers to these equations in simplest radical form, and sometimes we have to make decimal approximations. Okay, so for exercise 4 it says, express your answers in simplest radical form using the quadratic formula. Okay, and it says find the solution. So this right here, keyword find the solutions, mean I need x equals something at the very end. So I'm going to use my quadratic formula for both of these. My suggestion right now would be to pause the video and try to do these 2 problems on your own. Okay, and then see if you do them correctly when we come back. Okay, so I would pause right now, try to do A and B using the quadratic formula on your own, and then unpause when you're finished and check out the work that I do. Alright, so the first thing I'm going to do is find A. A is that invisible 1 right here. B is 6. And C is negative 9. Okay, now I'm going to take all of those values and I'm going to plug them in. So x equals negative b plus or minus the square root. Okay, b squared minus 4 times a times c, all over 2 times a. I like setting this up this way because it reminds me to keep track of my signs. So b is my first thing, so I have a 6 here, then a 6 goes here, then I'm going to plug in a is 1, so 1 goes here and here, and then c is negative 9, so I have a negative 9 here. Okay, and now I'm going to simplify. X equals negative 6 plus or minus the square root. 6 squared is 36, and negative 4 times 1 times negative 9 is a positive 36. So I get 36 plus 36, and then 2 times 1 is 2. Keep simplifying. I get 6 plus or minus the square root of 72, because 36 plus 36 is 72, divided by 2. Now I have to take this square root of 72 and I've got to reduce it. So I'm going to take my green color. I have to reduce this square root of 72. So the square root of 72 is the same thing as saying 36 times 2. And I know that 36 is a perfect square. So the square root of 72 is really 6 square root of 2. So I've found out my reduction there. And now when I rewrite it down here, instead of writing the square root of 32, I'm going to say 6 plus 6 square root of 2 over 2. Okay, last step, I'm going to do my butterfly and divide each of these by 2. 6 divided by 2 is 3, so I get 3 plus or minus 3 square root of 2. Okay, that is my final answer. For letter B, same thing. Going to find A, B, and C. A here is a positive 3. B is positive 4. And C is negative 1. Now I'm going to plug them into my formula. X equals negative B, so make parentheses, plus or minus the square root of B squared, so parentheses squared, plus or minus 4 times A times C, all over 2 times A. Now I'm going to go back and plug everything in. I have a 4 here for B and a 4 here for... What just happened to my screen? Sorry, I accidentally pushed the left button. Okay. 4 here for the other B. And then I'm going to plug in A. A is 3, so I have a 3 here and a 3 here. And finally C is negative 1, so I'm going to plug in a negative 1 here. Now that I've plugged everything in, I'm going to start simplifying. So the first thing is to get this negative 4 without the parentheses. So I get negative 4 plus or minus. 4 squared is 16. Oh, I did not mean to put a plus or minus here. Sorry, this should just be a minus symbol. So negative 4 times 3 times negative 1 is going to give me a positive 12. All over 2 times 3, which is a 6. Okay, so then I'm going to keep reducing. Negative 4 plus or minus the square root of 28 divided by 6. Now, 28 is not a perfect square, so again, I've got to take this 28 here, and I've got to reduce it. So I get the square root of 28 is really the same thing as the square root of 4 times the square root of 7. So I end up getting 2 square root of 7. So when I reduce, I'm going to now write x equals negative 4 plus or minus 2 square root of 7 divided by 6. Okay? Now, when I do my butterfly right here, this is not going to come out to a whole number. It's going to come out to a fraction. That's okay. So I'm going to have negative 4 divided by 6 is negative 2 over 3. And 2 over 6 is a 1 over 3. So I reduce my fraction of 4 over 6 to 2 over 3, and I reduce my fraction of 2 over 6 to 1 over 3. Okay? So when I want to finally rewrite this, I don't want to leave that 1 there, so I'm going to rewrite it as x equals negative 2 plus or minus the square root of 7 all over 3 as my final answer. Okay? So a lot of math going on here. Please watch your signs, use your calculator to help you, and please don't forget to reduce your radicals like I did with the green. Okay? The last exercise in this lesson is a word problem. Well, most quadratics deal with word problems, so this word problem is to practice the quadratic formula and then to show what it's like to convert it to a decimal. So exercise 5 says a projectile is fired vertically from the top of a 60-foot building. Its height in feet above ground after t seconds is given by this formula. Using your calculator, sketch a graph of the projectile's height using the indicated window. At what time does the ball hit the ground? So this, when you see the word ground in a word problem, this means the zeros. It means solve. Okay? So let's do the sketch first, and then we'll solve this with the quadratic formula. Okay, so let's open my calculator, and on my calculator I'm going to go to graph. I'm going to get a new graph on my screen, hit Control N, do not save changes. Control N. add graphs. Okay, and then I'm going to type in my equation. Now, you can't put a t in here, you have to put an x. I'm going to put negative 16x squared. Oops. Negative 16. What is happening with my calculator? I clicked something and now it's not working. Let's try to open a new one. There we go. Alright, negative 16 x squared plus 20x plus 60. Now when I hit enter, this graph might not show up. Yeah, see how it shows up as two lines? Well, I have to adjust the window. So see how in this picture on this graph over here, my y goes up to 70 and starts at 0? So I'm going to go to Menu, Window, and Window Settings. And I'm going to make my x minimum 0, and my x maximum looks like it's 3 on this picture, on this graph. So x maximum is 3. My y minimum is going to be 0, and my y maximum is 70. So I'm just looking at this picture here that it gave me, and I'm typing in what I want my minimums and maximums to be. Hit OK, and there I can see my graph. And it does kind of look like a launch. If this was the building and I threw something off of it, this is the path it would take. Okay, so when I look at my sketch is going to kind of look like this. Start here, and I kind of go down like that, right? That's my sketch. Okay, so now let's solve this using the quadratic formula and see where the ball actually lands. To me, in my sketch, it kind of looks like it hits after 3, but I know that's just a sketch. Let's actually see what the real value is. So the first thing I'm going to do is rewrite this with 0 equals. So negative 16t squared plus 20t plus 60. And I'm going to define a, b, and c like normal. So a equals negative 16. B equals 20, and C equals 60. Okay? And now I'm going to plug them into my quadratic formula. So x equals plus or minus, sorry, not plus or minus. Sorry. Negative b, so negative parentheses b, and plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'm going to plug in my a, b, and c. So first plug in your b. B is 20, so I'm going to plug in 20 here and here. Then plug in your a, negative 16 and negative 16, and then plug in your c into here to get 60. Now this is a time where using a calculator might come in very handy because these numbers are pretty big. Okay? So using your calculator would be really useful here. So when I start simplifying, I'm going to have x equals negative 20 plus or minus the square root. 20 squared, 20 squared is actually 400. So I get 400 minus, okay, 4 times negative 16 times 60 is actually 3,840. So if you plug this into your calculator, 4 times 16 times 60, you get this big number. So sometimes you have to use your calculator. Okay? All of this divided by negative 32. Keep simplifying. I get negative 20 plus or minus, oh, sorry, this is plus. Plus or minus the square root of 400 plus 3840 is 4240. All over negative 32. Okay. Now, when I use my calculator, I have 2 separate problems right now. So this is going to split. I'm going to have the problem of x equals negative 20 plus the square root of 42040 over negative 32, and I have the problem of x equals negative 20 minus the square root of 4240 over negative 32. Okay. So we're going to plug these into the calculator and help us get a decimal approximation. Okay, so the way I'm going to do this is I'm going to hit Control square root, get a square root symbol, 4240, I plug in as a square root, plus negative 20, oops, actually let's do it the other way. Let's do negative 20 plus this Control square root, 4240, and I'm going to hit enter. That will give me the number on top. Okay, I'm going to hit number, approximate to a decimal, convert to a decimal, hit enter. So I get 45.1153, but I still have to divide it by negative 32. So I'm going to divide that by negative 32, and I get negative 1.4 as this value. So negative 1.409, so it's negative 1.4. The other one, I'm going to do the other one, so I get negative 20. Now it's minus the square root, so control the square root symbol, 4240, hit enter. Your calculators don't do this convert to decimal thing because it already is a decimal. So I get this, and then I have to divide by negative 32. When I do this, I get 2.6, but this 2.65 actually converts to a 2.7, so I get 2.7. So when you're converting these decimals, please be really careful when you round. And notice as well that you get two solutions, but only one of them can be correct. This is a positive, in real life situations we can't have time be negative. So this solution can't work because time can't be negative. So your only answer is this 2.7. So at 2.7 seconds, the ball hits the ground. Good luck on your fluency, and you do mastery after you do 13.5.